lecture number 7 of a chapter solution, and we'll be studying about relationship between molality and molarity. Small m is molarity, capital M is molarity. Now student, there's one formula for a relationship between molality and molarity. Molality is equal to 1000 m upon 1000 d m2. Now what is this capital M? This capital M is molarity. This small m is molality, right? What is this D? D is density of solution. Understand this, density of solution, right? This capital M is again molarity, and this M2 is molecular weight of solute. Okay, now student, we have to prove this formula. Right? Which formula? This. But before moving to prove it, we have to understand the formula of molarity and molality. So first let's understand what is molarity. What is the formula of molarity? Molarity is number of moles of solute. Here 2 stands for solute and N stands for moles, right? Number of moles of solute, and here volume. Whose volume? Volume of solution, and that has to be in liter or dm cube. I have taught this before. If you don't understand it here, see my previous video on molarity. The link will be given in the description, right? Now let's see what is molality. Molality formula: M is molality, number of moles of solute, like molarity, but here we don't take volume of a solution. Instead we take weight of solvent. Understand student, this W1 is a weight of solvent, and this is expressed in kg, right? But suppose I write this in gram, right? Then after here I have to multiply by 1000. Clear? Got that? I write here 1000, but if this is in 1000, then obviously this has to be in grams. Okay, now student, to prove this formula we have to understand first how the molarity is prepared. Molarity, let's understand. Suppose I say I have a solution, right? This is a solution. How this solution is prepared? This solution is prepared by adding some amount of solute to this solvent, right? After adding this, what will form? It will form solution, right? Now, to obviously this solution, now this is solution, understand student, this is solution. So if it is a solution, it will have certain concentration, right? And suppose that concentration is expressed in molarity, right? And this molarity will contain obviously some moles. Understand this. Suppose I say I prepare a solution of let's say 2 molar, right? So what does it mean? It means that per liter of the solution contain 2 moles, right? If I say molarity is 5, then the number of moles will be 5. If I say molarity is 1, then the number of moles will be 1. Right, student? Clear? So it depends upon what is molarity. Right? Suppose I say the molarity for this solution is n molar. What is that? N molar. N number of moles is present in 1 liter of solution. So the molarity is n molar. Right? So the molarity of this solution is n molar. Obviously, if I need to find out molality, I should know what is molarity and I should also know what is density, right? Suppose this solution has some density, and let's take it for simplicity. Density is 1 gram per ml. What is density? 1 gram per ml, right? Clear? Now molarity is equal to number of moles of solute. W1 is weight of solvent in kg, but if this is given in gram, here we multiply by 1000, right? Now student, we need to find out weight of solvent, right? Now what is weight of solvent, right? Weight of solvent W1 is equal to weight of solution minus weight of solute. From a solution, if I remove solute, what will be left is a weight of solvent, right? Okay. Now this is what we require in this formula W1, right? Now let's understand one thing. Suppose I have a solution, I draw over here. I have a solution, right? Solution will contain some moles, and that mole I write here N2, right? This solution will have certain density. That density, suppose is D, or I can take 1 gram per ml. And the molarity of this solution is, suppose I say N2 molar, then volume of this volume will be volume of solution, because we are talking about molarity, right? Understood this point? Here, now student, suppose I want to find out the weight of this solution, but we know volume of a solution, we don't know the weight of solution, but we do understand a formula which converts volume into weight, and that formula is density. So if I find density, if I know density of solution, that is 1 gram per dm cube, and density is mass upon volume, so mass, that is weight of a solution upon mass upon volume of a solution. What I know volume of a solution, I know density. Can I find weight of a solution? Yes, weight of solution will be volume of a solution into density of a solution, right? So instead of weight of solution, I can write density into volume of a solution. Now what is volume of solution? Since it is given in molarity, volume is 1 liter. Or volume is 1 liter, that means it is 1000 ml. So here I can write 1000, right? So weight of solution is density into volume, density into 1000. This is weight of solution. Now what I need weight of solute. Now student, what I know from here, I know number of moles of solute, right? So if I know number of moles of solute, and we don't know that number of moles of solute is weight of solute upon molecular weight of solute. So weight of solute will be number of moles into molecular weight. So I can write here N2 and molecular weight of solute. Understand, student? Now one thing very important. Can I write N2 as M? That is the question I'm asking. Can I write N2 as M? Answer is yes, I can write. How I can write? Let's understand. Suppose I say the molarity of this solution is 2 molar. Suppose I say the molarity is 2 molar, right? So if the molarity is 2 molar, then according to definition, how much moles of solute is present? Moles of solute present will be 2, right? Because molarity is 2 molar, so 2 molar moles is present in how much volume of a solution, student? Volume of solution will be 1 liter. 1 liter means 1000 ml, right? So when molarity is 2 moles of solute is present in 1000 ml. When molarity will be 5, that means 5 mole of solute will be present in 1 liter, that is 1000 ml again. If I say molarity is N, that means N mole of solute is present. Since it is solute, I can write 2, right? Okay, in how much? 1000 ml. So again, what I can observe is, whatever the molarity, say moles is present, means here molarity is 5, so mole is 5. Or I can say mole is 5, so molarity is 5. Mole is 2, so molarity is 2. If mole is N2, right, so molarity will be N, correct? Right, N molar, right? Means what I can say or I can see over here, or what I can observe is there, molarity and moles are same. So number of moles and molarity will be same. So I can write like this. Clear? So now this formula here, what I can write? I can write M. So molarity is equal to 1000 M, right? Here weight of solvent, I can write weight of solvent. This is weight of solvent. So I can write this, right? So I'm writing 1000 D. Instead of N2, I can write M. So M into M2. Now how this is the formula is derived. Clear? Right? So the first relationship between molarity and molality is derived over here. Now student, very important. If you don't remember the derivation, it's okay. But you should always remember, you should always remember this formula while solving the problems. Right? Now, I write here one question. Okay. Now, question is, a solution of 4.22 molar of, I write here, aqueous solution of sulfuric acid, H2SO4, right? Having density of solution, that is 1.21 gram per cm cube, right? You have to find molality for this solution. We have to find molality. Now, what they have given? They have given us molarity. What is density? 1.21, right? So just substitute in this formula, we can easily solve this. Okay, let's see how. Molarity is equal to 1000 M. What is M? M is 4.22, right? 1000 into density is 1.21 minus, what is molarity? Again 4.22, and what is molar mass of solute? Solute is what? H2SO4. H2SO4, hydrogen is 2, sulfur is 32, oxygen is 16, 16 4 is 64, total is how much? 98, right? Now, if you can easily solve this, right? Once we solve that, okay, the answer we get is 5.298 molar. Clear? Right? So this is a relationship between molality and molarity. Thank you, students.